Hello, this is Elijah Peters. This is week 7 of Data Structures and Algorithms. This week is going over the problem sets, mine specific or Java, what I program in. So let's get into it. So for the first problem set, we have a problem that the function calculates the sum of all numbers from 1 up to x, and then adds the initial value of y to that total. Then it uses y as a parameter to find the sum, while x is used as a counter to tell the function which number to add next and when to stop. Problem 2, you can see that this is the recursive implementation of selection sort. So it's a job to sort an array by shrinking the problem size, and then in each step it uses a helper function on the min index to find the smallest remaining element, and then swaps it into the current start index position. Then it calls itself to sort the rest of the array, which the recursion stops when the start index is moved across the array, which indicates that the entire structure is sorted. Getting into problem set 2, this function calculates the number of times you can divide n by 2 until it reaches 1. And the recursion piece is n being used as the input value and the parameter, and then having it and counting the steps until it's at the base case, Problem 2. This one, it uses recursion to print the binary representation of the integer n, and then printing the binary digits in correct order for most significant bit to least significant bit, and then followed by printing the remainder after the recursive call. Getting into problem set 3, this function uses recursion to print a pattern of asterisks that form a triangle, where each line has one more asterisk than the other. The final output will be n lines of asterisks, with the first line having 1 asterisk, the second line having 2, and so on, 3, 4, up to the nth line having whatever number of asterisks total. Getting into problem 2, this function prints a number in a specific order that follows a V or hourglass pattern based off its structure. It prints a value and goes deeper into recursion, and then prints the same value again when returning. The function explores like numbers by doubling n in the recursive step, but it has a maximum value set by the limit variable, or the global limit variable. Getting into problem set 4, this function specifically is a tree recursion, where the function calls itself twice inside the main body, and then it prints a sequence of numbers determined by how the counter x is decremented before each recursive call, minusing. So the x operator modifies the value of x before the function call or print statement, and these changes affect the remaining calls in the current function. Problem 2. This recursive function is designed to find and return the largest number or element in the given array segment, A, which is of size of n. The function works by repeatedly finding the maximum of the smaller portion of the array, and then comparing the result with the next element. Getting into problem set 5, this function calculates the product of the two input numbers, a and b, using a method based on repeating, doubling, and halving. This technique is often called the Russian peasant multiplication or Ethiopian multiplication method, which only uses addition, multiplication by 2, and division by 2. Getting into problem number 2, this function calculates the power of a number, so a raised by the power of b, using a recursive technique known as exponentation and squaring by squaring, or the method of fast power. This method reduces the number of multiplications required, making it much faster and simply multiplying a by itself b times. Getting into problem set 6. This function performs a recursive operation on a string that results in printing the first character of the original string multiple times. It's determined by the growth pattern related to the string's length, so the number exhibits tree recursion because it calls itself twice within the main body, leading to an increased number of recursion calls. Into problem 2. This code prints a sequence of numbers that is determined by the order in which the nested functions and executes and returns their values. So the core mechanism is for this function is it prints the current count, increments the count using the plus count, and then the innermost fun call returns a value, which becomes the input for the middle fun call, which in turn at the end returns a value that becomes the input for the outermost fun call. Just nested in each other. 3 funs. Problem set 7. This function is this calculates the nth Fibonacci number, which is the 5th number in the sequence, using recursion and a global variable to store the value needed for the calculation. It uses the static variable, or the static global variable, fp, to hold the f in parentheses n-2 value between recursion calls. The function fun_n is designed to compute the sequence, relying on the shared static variable fp to pass that f parentheses n-2 up to the call stack. Getting to problem number 2, this function uses tree recursion, so it calls itself twice to print a highly repetitive sequence of numbers determined by the input n. The function operates by completely exploring its recursive branches before finally printing the current value of n. This pattern is often related to the Catalan numbers due to its binary tree structure of the calls. The code generates a sequence by performing 3 steps in this exact order: recurse left, print, and then recurse right. These are the questions for the Geeks for Geeks. These are all recursion problems, different recursion problems, and that is week 7.